In this video, I will explain you AC applied across pure resistive circuit. So we have a resistance load here and this is applied with an AC input. Now how can we represent an AC input? It's an AC EMF, right? So EMF is equal to E0 sin omega t, where E0 is the maximum value of EMF. Okay. Now, as per Ohm's law, we know the equation to get the value of current. I is equal to V by R. Here, the applied potential difference is equal to E0 sin omega t. See, E0 sin omega t can also be written as EM sin omega t. So both E0 and EM represent the maximum value of EMF. That's all. Okay. So E0 sin omega t divided by R. So now I will get a new value, E0 by R into sin omega t. And our input, this is current. Our input was E is equal to E0 sin omega t. So this can be rewritten as E0 by R is nothing but the maximum value of current. So I can rewrite it as I0 sin omega t or Im sin omega t. Both are true. Now see one thing, I could say that both are in phase. What does in phase mean, you know? Let's say when one is increasing in this way and other also will be increasing in the same way. For example, voltage graph curve will be in this way. Okay, starts from 0 and goes to maximum value and then go to 0, negative maximum value, then 0. And when I am saying that current is in phase with voltage, which means that along in the same way that voltage is increasing, current will also follow voltage. The amplitude might not be the same, but both are in phase. So whenever here it is sin omega t, here also whenever in voltage it is sin omega t, here also it will be sin omega t. Now I will tell you how it can be out of phase. Okay. Now if it is sin omega t plus phi, then I have to say that current is leading EMF, which means whenever E is making an angle of 30 degree, then this will be making omega t is 30, right? 30 plus 5. 5 can be any value. It can be 90, it can be 10, it can be 20. So if phi is 20, then this will be 50. Now let me just represent you a curve, a graph where both of them are not in phase. For example, at one place E is equal to input, this EMF is the characteristics of input power source. So that cannot be a different value, that will always be E0 sin omega t. Now current is the property of that circuit where it has applied. So here I can say that current is, say for example, it is out of phase. So I0 sin omega t plus 90 pi by 2. Say for example, the phase difference is pi by 2. Now I will apply different angle for omega t. So first case I am applying the value 0 for omega t. At the same time, when omega t is equal to 0, what will be the value? So angle is 0, then E, this is angle theta or omega t, here E and I. We will draw a table. So when omega t is equal to 0, E is equal to E sin 0. What is sin 0? 0 itself. Now I is equal to I, omega t is 0, right? So 0 plus 90. So this will be sin 90. Sin 90 is 1. So I will be I0 itself. Now at an angle of 90. At an angle of 90, sin 90 is 1. So E will be E0 itself. Now I is equal to sin 90 plus 90, 180. What is sin 180? 0. So this will be 0. 0 into I0 will be 0. And just one more thing, 180. So this is E0 sin 180, which is 0. Now here it is omega t is 180. 180 plus 90, 270. Sine 270 is minus 1. So I is equal to I0 into minus 1 minus I. This is just an example, okay? So this is not a representation of AC circuit with pure resistance. If at all, if that is out of phase with current leading by an angle of 90, this would be the scenario, okay? Don't get confused. Now how can we represent it on a curve? See, EMF starts from 0 and goes to maximum value in 90, then comes to 0 at 180. So the curve will be in this way. But see, current at 0, it is I0, which means at 0 angle current is here. That is the maximum value. Now at 90, what is the value of current? 0. So at 90, current will become 0. Now at 180, current is minus I. So this is 180. So here it is maximum. Now it is coming in this way. See, this starts from 0 and goes in this way. So this, in the case of EMF, it is in between 0 to 90. EMF increases from 0 to maximum value E0. But 0 to 90, what happens to current? Current decreases from I0, maximum value to 0. So I decreases from I0 to 0. So this would be the case of out of phase. But here in this case, both are in phase. Now how can we represent it in a phase diagram? Don't get confused. Here in this case, in the case of pure resistive circuit, we have a resistance and it is connected by an AC input having a value of E0 sine omega t. Okay, so from there I got the value of I, which is equal to E0 by R into sine omega t. So I0 is the maximum value, that is E0 by R. Very important relation. This can be written as I0 sine omega t. Now current, see inside sine we have omega t here. So current varies according to omega t, sine omega t, and here also it is varies according to sine omega t. Both are in phase. Now I will give you one more example. Okay. Let's say a train is taking a path in this way. Now train will have a guide and let's say engine driver is here very near to engine, and at the back end we have guide. So this is guide and this is driver. Now we know this is north, east, south, west. Now when here at this position, when engine is moving in this direction, both driver and guard is moving towards east direction. Now I can say that both of them are in phase, moving in the same direction. Now the same engine, if it has taken a turn and engine is here and driver is here, and if the guard is here, then I have to say that driver is moving towards east and guard is moving towards driver is moving towards north and guard is moving towards east. Now when the train is here, engine here and guard here, now driver is moving towards west and guard is moving towards north. So they are out of phase now. Both of them are following two different directions. But both, see, this movement of guard is an outcome of movement of engine. So always this is the cause and current is the result produced, effect produced. Okay, so always this is the cause and movement of engine is the cause. But when engine is moving in this direction, engine got one direction and the guard got different direction. So in this way you can make an analogy. Okay. So we got the value of current, we got the value of maximum value of current. This is the value of EMF. Now 1, 2, 3. Now how to represent it in a phasor diagram? Now I will explain you what is phasor diagram. Let's say this is XY axis, and this I am going to consider a vector, an arrow having the size is equal to the maximum value of EMF, that is E0. So this is the length of this arrow, and this arrow I am going to call it as phasor. Okay, now with respect to X in counterclockwise direction, if it is making an angle of omega t, just take the projection of this phasor along x-axis and along y-axis. Now the x component will be E0 cos omega t and y component will be E0 sin omega t. Now just see that the phasor is being rotated in clockwise direction. So always the angle will be measured with respect to x-axis in counterclockwise direction. Sorry, the rotation is in counterclockwise direction. Okay, the rotation is counterclockwise direction. At any moment, if you are doing this projection, so next position, it will be at this position. Now the projection will be here. Now this angle will be omega t2, and the projection is this, and that is E0 sin omega t2. Now initially here, and its projection in y-axis it will be 0. So when t is equal to 0, the value of y projection will be 0. So always take the y projection, and that will be giving us the instantaneous value of current. See, E0 sin omega t. So instead of representing AC in this way, see the AC in this way, I have an x-axis, I have a y-axis, x-axis and y-axis. Instead of representing AC in this way, I could easily represent the same AC as a phasor having the total length of maximum value of EMF. So this would be the maximum value of EMF. What is that value? E0, rotating in counterclockwise direction. And its y projection will be the instantaneous value of EMF. Else what I have to do is I have to represent it in a curve. So this is the best representation, right? With two lines it would be done. One line representing the instantaneous value of EMF, that is y projection of the voltage phasor will be representing the instantaneous value of EMF, and this represent the instantaneous value of, this is current, this one is current, and the length of this is maximum value of current. I can say it as I0 or E0 by R. Now see, I have to say that in this diagram both of them are rotating, but as both of them are in phase, the angle that EMF phasor makes with respect to X and the angle that current phasor makes with respect to x-axis, both should be same, because here it is omega t and input also E is equal to E0 sin omega t. So both the angle should be same. But if I am representing in this way as voltage for this and this for current, then this is wrong, because see there is a phase difference, which means both phasor is making an angle in between. If both of them are in phase, then the angle made in between EMF and current should be 0. So how can I represent it? I should draw an XY axis, and this is EMF, and EMF is making an angle of omega t with respect to x-axis. How come we know this? Because I know the angle is omega t, and its projection on y-axis will be E0 sin omega t. This is only possible when this length is equal to E0. Now I should draw current in the same phasor diagram, but we know that the maximum value of current will be bit less than EMF, because EMF divided by resistance is the maximum value. Maximum value of EMF divided by resistance is the maximum value of current. So I could draw a new phasor that has got a lesser size. Now the angle in between this phasor and this phasor is 0. So I can say that both are in phase. In phase means rotating together. See, rotating together. So this is this size should be I0. And how to get the instantaneous value? Just take the projection and this will be I0 sin omega t. And this is very, very important. Okay. So you should know the graph, and if this is representing the variation of voltage, this should be the representation of variation of current. Now how to get the value of power consumed, instantaneous power. So power consumed is equal to, I can find instantaneous power and average power. So it would be better if we calculate the average power. Anyway, instantaneous power instantaneous is equal to instantaneous voltage into instantaneous current. I into V or V into I. Both have to be instantaneous. So what is instantaneous voltage? E0 into sin omega t. And what is instantaneous current? I0 into sin omega t. So this is instantaneous power. Now when we are integrating it in between 0 to t, we will get the average power delivered in one cycle. Okay. So that is instantaneous power, you will get E0 sin omega t into I0 sin omega t. Now average power is equal to 0 to t summation of this. Okay. So this will be E0 into I0, I can take outside, sin omega t into this is sin omega t into sin omega t, that one is sin square omega t. So and dt would be there. Okay, so 0 to 0 to t. And I have told you last time cos 2 theta is equal to 1 minus 2 sin square theta. So sin square theta is equal to 1 minus cos 2 theta divided by 2. So this would be equal to E0 into I0 into 1 minus cos 2 omega t divided by 2 integral 0 to t. Now this is equal to E0 into I0, 1 by 2 will come out, multiply it inside. So E0 into I0, 1 by 2 integral 0 to t minus 0 to t cos 2 omega t by 2. And I have told you that integration of cos or sine function over a complete cycle, it would be 0. Okay. Now this will be 1 by 2 will come out, E0 into I0, 1 by 2 will come out, and this will be integral dt will be t. Now put upper and lower limit, so t minus 0. So to get the average we have added, right? To get the average value we have to divide it with t. Divide it with t. We have to get the average value. We have added, now we have to divide it with t. So while dividing with t, this t and this t would be, t minus 0 is t, and that t and this t would be cancelled, and I will get the value as E0 by root 2 into I0 by root 2. Basically it is E0 into I0 by root 2 into root 2 2. See, E0 into I0 by 2 it is. Why I have written in this way, you know? E0 by root 2, what it is? ERMS. I0 by root 2, what it is? IRMS. So I can say that this one is equal to P average equal to ERMS into IRMS. So we will take it as PRMS. Okay, this is the average power. This is the rated power. Rated power is equal to ERMS into IRMS. Okay, thank you.